to record the session and let me share the screen again. And talking about, we've also talked about like why robotics, and today we wanted to focus about like to prepare students for their future job skills. As we all aware, actually, the world nowadays has been changed a lot. Like there is growing demand for robotics. Like there are some data to support this. For example, the market size for global robotics technology was valued like 62.75 billion in 2019, with projected growth to 189 billion by 2027. And like industries such as healthcare, education, engineering, manufacturing, and more are increasing their reliance on robotics. I'm not going to too details, just wanted to provide some of the key facts here to support this and to let our students know, because a lot of times students, they don't know why they need to learn about robotics. And also talking about the automation, actually report by McKinsey says that 60% of occupations have at least 30% of constituent work activities that could be automated. That's the way actually as educators, we really need to prepare for our students for their future, especially for the robotics in manufacturing industries. Actually, it's kind of even common sense now that manufacturing is one of the industries that widely adopts robots. And I just mentioned, like the future of work is different, it's changing, tasks change, jobs change, technology changes. And we hope it's not human versus machines, it's humans enabled by machines in the future. And there are increasing career opportunities in the world. Actually, I just provide some of the examples here, like data scientist, software engineer, like AI research scientist. All those jobs are, we can see this trend, like increasing career opportunities. So as educators, it's vital for us to prepare our students for their future skills and career readiness. Okay, so what is the V5 Workcell? The V5 Workcell is an introduction into the world of industrial robotics. And it is an 5-axis robotics arm, conveyor, and sensor construction system, as you probably can see from this image. And combined with the VEXcode V5 software, so that's the coding software for our VEX V5 as well. And this is for vocational education and industrial robotics and automation system. We mentioned it's for vocational education, but it can also be, for high school students where they want to know more, about the bridge to educational robotics to industrial level robotics. And here is a quick video about the introduction for Workcell. I also wanted to share that with you.
There are nearly 2.5 million STEM jobs going unfilled in today's workforce. Here at VEX Robotics, we're working to close the skill gap by improving workforce development education. Using our advanced V5 technology, we've created a means to educate students on the fundamentals of collaborative problem solving in a way that's accessible to everyone with a low barrier of entry. Introducing VEX Workcell. Designed for career and technical education, Workcell combines our proven VEXcode software with hardware components like motors, sensors, and electronics. Workcell acts as a primer, introducing students to manufacturing concepts like construction, palletizing, and coordinate planes to give the workforce of the future a foundation of understanding. Students will take control of their Workcell using VEXcode V5, available on all devices. VEXcode is a coding environment that meets students at their level. Novice coders can start coding with blocks, while more advanced coders can use Python or C++. Whether it's blocks or text, all students can use VEXcode's tutorials, example projects, and built-in help to code their V5 Workcell along the way. We've also created STEM labs to support educators with free, easy-to-follow lessons that align with educational standards. Each STEM lab contains important concepts like factory automation in the form of guided explorations that encourage teamwork and collaboration. The teacher portal contains instructional planning and support that includes teaching guides, strategies for differentiation, integrated teacher notes, and more. Together with the REC Foundation, we're bringing a new challenge to career and technical education with the Factory Automation Competition. This classroom-based competition allows students to connect and apply what they've learned through objectives that emulate real industry scenarios. This competition is completely remote, meaning teams from around the world can compete for the best throughput and runtime from their own classrooms. The FAC also evolves annually, so students will be able to reconfigure their work cell to fit the new objective each year without the need for new hardware. VEX Robotics also cares about your development as an educator. That's why we offer over 17 hours of free online professional development to advance your skills in STEM. This course is self-paced and gives you the tools needed to facilitate meaningful learning experiences for your students. We're committed to enhancing career and technical education by providing a clear path for students to prepare for advanced manufacturing careers. This is the future of Industry 4.0. This is VEX V5 Workcell.
That is a very brief introduction of what is Workcell and how does Workcell bridge the gap between the classroom and workforce. There are also like two animations, two videos here. One is about the factory robotics and the workplace. Actually in the factory, the workplace and factory robotics, and on the right is the robotics, factory robotics in the classroom as a comparison. As you can see from the left, that's the factory robotics in the workplace. That shows is a real life 5-axis robotics arm for automatic palletizing, and also like packaging and sorting and manufacturers. What we know, like palletizing or palletization mostly refers to the act of placing those products on the pallet for shipment or storage and logistic supply chains management. So increasingly automated systems are taking over the task of palletizing products. You can compare that with the VEX Workcell. It's a more complex, but the basic principle is actually the same. Sensors are used for detection, and robotics arms are used for sorting and stacking, as you can probably see from the video. And on the right is actually our VEX V5 Workcell. In order to teach students about this industrial robotics in vocational education, what we have done is we have created this, let me turn that on again, this video. What we have created this really cost-effective industrial robotics Workcell model that can be used in a classroom setting. And this model is small enough, you can see it's actually pretty small. It's small enough to be placed on a classroom desk and makes the Workcell accessible in a variety of educational settings. You can see it also has a 5-axis robotics arm. So it has a lot of different points of movement here. And we can extend, can move from side to side, and can also pick things up and go down. The robotics arm that's gonna move along the Cartesian coordinate systems. And not only do we have this robotics arm itself, but that also has different ends of arm tooling. I will be able to share with you more examples of different arm toolings of this Workcell. For example, we have like electromagnets, and we can place a pen at the end of this arm. And you can also see there is a conveyor systems, which gets into palletizing. It's, of course, the safety is the major concern here in the classroom. So this is pretty safe by also being a smaller size, and as well as having the ability to program the bumper switch that function as an emergency stop if needed. So that's the safety concern here. That's about the Workcell. And talking about the Workcell kits, there are two options available, two different kind of kits. The first one is the complete kit, and including the brain, battery, smart motor, sensors, and also different kind of construction components. And there is a different one, and that's no control system. Does not include the control system. That's a different kit. Because actually you can use the V5 control system to control and monitor the Workcell. Like the brain is exactly the same as you can see, and also the sensors. The major difference is the conveyor systems and also the other tools with this Workcell. As I just mentioned, there for the Workcell, the kits, this is the full kit. The full kit, there are 3 different storage bin, which means there are 3 different categories of the parts. The first one is the hardware. All of the hardwares actually are in storage bin 1. that contains the hardware to build the V5 Workcell using the Workcell STEM lab. It includes structural parts like motion components, like also some IQ parts and some Workcell specific parts. And the second box, second storage bin, are the electronics and tools that contains all of the V5 electronics. For example, the V5 optical sensor, electromagnets, line tracker, bumper switch, and everything else. That's the storage bin 2. And the storage bin 3, the competition hardware, it contains the additional parts to assist with participation in the factory automation competition. And my colleague Eve, she's going to tell you more about the the competition, the factory automation competition in the later slides. So for this Workcell, what we really want students to achieve is this manufacturing workforce readiness and also the hands-on technical skills. Of course, the other soft skills like program solving and collaboration skills. Those are the soft skills we want students to achieve. Talking about the most key areas for all our VEX products is our curriculum and educator resources. For Workcell, it's the same. We provided everything to educators. The first one is the Scaffolded Workcell STEM Labs, and everything is online as well, the same as the other platforms. The major difference for VEX Workcell STEM Labs is actually the STEM Labs are scaffolded and it's not function as plug-in lessons. So you have to follow the sequence of the STEM Lab. Probably, for other STEM labs, for other products, you can actually pick and, choose the STEM labs according to your curriculum at school. And you can pick several units. But for Workcell, you have to follow the sequence. That's a scaffolding progress. I will share with you some examples later. And then the educator training, I'm not going to details. It's also about the certification. The educator free certification course also includes Workcell. And coding, as I just mentioned a moment ago, for the coding, it uses VEX V5, VEXcode V5. So if you know how to use other platforms, code other platforms, so it's pretty easy for Workcell. And also we have this knowledge base, that's the STEM library, and you can check all the information and all the questions you've got and find solutions there. And then here is actually the example of the Scaffolded Workcell STEM Labs. This is the course outline. It provides both student-facing and teacher-facing courses and materials. The teacher-facing content provides all of the resources like the teacher's notes and the assessments and everything else. So it enables teachers to plan, teach, and also assess students. I just mentioned a moment ago, different from other STEM labs, Workcell STEM labs are scaffolded, not plugged in, and you have to teach them in order. For example, you have to build the arm first. It teaches about the moving, how to move the arm and program the arm. And then the next lab would be using the arm to pick up and drop off things with different sensors. With arms and also sensors. And then it's about the introduction to the conveyor program and the conveyor system. So that is structured in a scaffolded way. Just a glance of different labs, just wanted to give you, a walkthrough of different labs. For lab 1 and 2, students will build a Workcell for the first time, and then they can gain some building skills and learn about the safety, because for Workcell and also for industrial, even for industrial level robotics arms, safety is, the prime concern. So we want students to be able to understand the safety here. And also like the emergency press. For lab 3 and 4, students begin to explore how the arm of the Workcell moves in 3D space, both manually and they can also program that. So they are also introduced to attaching different arm toolings and arm toolings. For example, here you can see they attach a marker to the arm. And that can mimicking the industrial robotics arm at the end. At this robotics, the industrial tool at the end of the robotics arm. And lab 5 and 6, students will continue to build on the concept of movement by programming the arm to move with variables and to-do list. So they will be learning some advanced concept there using, variables and to-do list. But for labs 7 and 8, after studying both manual and automated movements, students will then dive into more manufacturing simulations by picking up and placing discs using electromagnets, and they can learn about the sensor feedback. Those are the key for lab 7 and 8. And then for lab 9 and 10, students are then introduced to the conveyor system and how sensor feedback can be used in material handling. Those are the key for labs 9 and 10. For 11 and 12, the STEM lab includes by allowing students to combine and apply their learning from all of the previous labs to investigate cooperate systems and how to make the Workcell their own to prepare for competition. So this is a quick walkthrough about the Workcell STEM lab from lab 1 and 2, and you can see the progression there. And it's the same for all our platforms. We provide you with pacing guide for educators to refer to and how you better understand each lab and plan your lessons. For Workcell, as you can see, we outlined the time, whether you need a half week or a week time or 1.5 week time to do that, and the description, the key concept for each lab, and also what kind of builds it involved. And also you can see the key concepts at the last column. And for the following slides, I will pass it to Eve, my colleague in VEX Academy. She will be giving you some examples of using Workcell. Here we present that in 2 broad steps. The first one would be build it, how you can build Workcell and what kind of builds, what kind of things you can done with Workcell and what are some of the key builds involved in Workcell. And then after talking about build it, she will be sharing with you like code it, like the key concept and what are the key programming or computational thinking you will be able to learn from Workcell. Okay, I'll pass it to Eve. And at the same time, if you've got any questions, please leave them in the chat box, or you can actually unmute yourself and just let me know.
Okay, can you hear me?
Yes.
Okay, I'm going to sharing my my screen. Okay, I'm Eve, the robotics training teacher of VEX Academy. The V5 Workcell allows students to engage in building, incorporating the physical building of robots into industrial robotics education, gives them the opportunity to bring abstract concepts and the equations of physics, engineering, and math to life. Practicing these STEM concepts in context also allow them to see how they are applicable in industry. The different builds are provided in building instructions, which guide them through step-by-step building, just like all other platforms. This makes building the V5 Workcell accessible for the students who may not have any experience building in general, building with metal or using tools. Here shows some of the parts here shows the parts of the building instructions of lab 1. I believe the building instructions will boost teachers' confidence. And if you've compared Workcell with other robots in the market, you will find most other smaller and the most cost-effective industrial robot models come pre-assembled and are often only built for one function. And an advantage of the V5 Workcell hardware is that students are not limited to one built robot. As the left image shows, they can build Workcell using parts from the V5 system, which has numerous different builds, including the basic functions of the robot arm. This gives them experience in not just building the robot arm itself, but the entire small-sized manufacturing Workcell model. This allows them to engage in a building process that highlights mathematical, engineering, and concepts which they would not be able to experience without building. This also allows them to understand how the Workcell operates on the physical level, which transfers to programming as well. Workcell build utilizes no tool on the end of the arm when exploring different types of movements along the Cartesian coordinate systems. In addition, adding multiple conveyors and sensors or changing the end of arm tooling can make the robot more versatile. Here we can see an electromagnet added for the arm tooling for picking up and place discs. And on the right, a marker attachment holds a dry erase marker. This is used to draw on the whiteboard. The VEX V5 Workcell is also composed of other metal, plastic, electronics, and sensors to build the conveyor systems. In the left picture, the yellow highlighted conveyors and the blue diverter are built from metal PCs, tread links, and motors. The system also encompasses many electronic components and sensors to automate the V5 Workcell and mimic true manufacturing processes, such as sorting and palletizing based on different conditions of the sensors. Workcell also allows several systems to be combined together to promote collaborations between students. After building the robot is now coding. In order to operate, repair, and maintain the automation, it requires workers to have a strong knowledge of programming. The VEX V5 Workcell allows students to program an industrial robotic arm model using VEXcode V5 and VEXcode V5 Pro. Beginners coders can get started coding with blocks, while more advanced coders can use Python or C++, or even VEXcode Pro, which is the coding environment real programmers use every day. Now I'm going to provide you with an example of coding the bumper switch and the electromagnet to pick up and dropping off objects. The V5 electromagnet is a manipulator, which will allow the arm to pick up, hold, and drop off discs. Bumper switch can detect physical pressing and is mainly used here as an emergency switch. We can watch this video. It simulates the picking up and the dropping off of targets by industrial robots in real life. You can build a project with a user interface on the brain screen so that each box corresponds to a specific movement of the arm. The user interface will display 4 colored boxes: white, red, green, and blue. Each color corresponds to a particular movement of the arm. The white box will move the arm to the disc pickup location, and each of the colored boxes will move the arm on to that colored disc drop-off location. Here is an easy programming sample. This is one of the steps to complete the whole program. You will be able to find the sample project in VEXcode V5. As we mentioned before, in our real world, a very common type of industrial robots are pick and place robots. As the name implies, these robots pick up objects in one location and place them in another location. This process can take place at any point along the path of the manufacturing of a product. Palletizing by a robot can be done by a worker controlling the robot. However, most of the time, vision sensors, color sensors, barcode readers, and other types of sensors control the robot's behaviors. These behaviors can take place by objects being moved on and off of conveyor systems, or even having objects passed from one robot to another. So Workcell has a connection with robotics palletizing in real industry. Another important part of the Workcell is conveyor systems and the required sensors. For example, you can add 3 line trackers and an optical sensor and code them to move disks along conveyors. This video shows how the conveyors, diverter, and arm will move. Students will build a VEXcode V5 project by using my blocks and the sensor feedback to divert red disks off of the conveyor system and move a green disk through the system and to its location. In the whole process, optical sensor can determine the presence and the color of a disk. Line tracker will first determine if a disk has been successfully loaded onto the transport conveyor. After that, line tracker will determine if a disk has passed the diverter and is ready for pickup with the arm on the Workcell. Finally, line tracker will determine if a disk has been discarded off of the Workcell via the exit conveyor. In this example project, my blocks will be used to define how the conveyors should move once a particular color of a disk is detected. The robot has different reactions when different colors are detected. Conveyor systems are used throughout manufacturing. They move material from one place to another for specific purpose. This is a wide range of conveyors and sortation equipment that can be combined into material handling solutions. On the right is an example of accumulation conveyors. This represents conveyors designed to transport items and can store items in a queue and to wait for downstream equipment to be available. Before teachers start the lessons, we have some different education resources for you. The first one is free online training and certification. You will learn the specifics about the V5 Workcell, the utilize the sensors, and how to utilize the STEM labs within your classroom. There are 2 videos in each unit. One video teaches you the concepts. The other one video is about pedagogy. Next, we have VEX Robotics knowledge base. It's a library of articles in which you can quickly find information about the V5 products, services, and the support contents. What's more, VEX PD Plus is a community learning platform that enables educators to learn from and interact with experts in classroom and competitive robotics. PD Plus members have a network of resources and receive year-round coaching and feedback from VEX education experts who value STEM learning and pedagogy. PD members also able to experience the most inspiring STEM education event on the planet, the VEX Educators Conference, held at the VEX Robotics World Championship. For more information to access the VEX PD Plus, you can go to pd.vex.com. The last part I'll introduce is FAC, the Factory Automation Competition. It allows students to connect and apply what they have learned by simulating real industry scenarios. This competition is completely remote, meaning teams from around the world can compete for the best throughput and runtime from their own classrooms. The FAC also evolves annually, so teams will be able to reconfigure their Workcell each year without the need for new hardware. While participating in the competition, students learn desirable and applicable robotics manufacturing skills, STEM principles, and the soft skills like communication and teamwork. The theme for 2022 to 2023 season is quality control. Teams will design, build, and program a manufacturing Workcell. Participants will compete by submitting a video of a production run to robotsevent.com, and their scores will be recorded on a global leaderboard. Based on their scores at each competition phase, teams are going to achieve the highest global rank. This is created to help close the STEM skills gap and provide a unique classroom competition opportunity for high school students. The FAC program allows them to experience manufacturing robotics and developing skills they can bring into the workforce. And that's it for the main part of today. Here is a Q&A session. I will pass it to Kelsey.
Thank you, Eve. Thank you, everyone. Let me know if you have any questions. Feel free to unmute yourself if you have any questions.
Kelsey, am I the only one here?